All right, everybody. Hello, my name is Jason Shepard. I am the president of AFCOM's Southern California chapter. I'd like to welcome everybody to our third quarter 2023 educational series webinar. Before we get started, what I'd like to do is invite our board to introduce themselves. And Dial, why don't we start with you first?
Hello, everybody. Diane Craviel-Delson, owner of DKKD Staffing.
Hey, good afternoon, everyone. Brad Schulteis here, LDP Associates.
Hey, folks. David Sipes here with Senior Director of IT for Zempleo.
Hello, this is Yeet Bullitt with EYP, Mission Critical Facilities, part of Ramble. And I am the director of our engineering design group for data centers.
And we also have two guest speakers on the call today. Why don't we start with Todd and then Spiros?
All right, good afternoon. Todd Sword with Southern California Edison Economic Development Services Group.
Good afternoon, Spiros Leolis, part of the EYP Mission Critical Facilities, part of Ramble now. Thank you.
So what we're going to go get it kicked off. What I'm going to do here is start sharing a few of my slides. So our agenda today, we'll go through some welcome announcements. We'll talk about the supply chain updates, an update from Southern California Edison, and we'll get to our keynote session today, which is EYP's discussion of generative AI and its impact on the data center facility itself. What I'd like to do is, before we go too much further, again, address our calendar, upcoming events. AFCOM, the national organization, has their webinar on the race to AI on Tuesday, October the 3rd. There's the link there. In addition to that, Yeet and I are both speaking on a panel discussion on the future of data centers at the Biltmore Hotel on Tuesday, October the 17th in downtown Los Angeles. If you'd like to register for the event, you get the link right there, or just search SDF.org, and you can register for the event there as well. I also want to bring to everyone's attention that we are going to have a holiday social again for the chapter this year. Last year we did it at the Left Coast Brewery in Irvine. This year we're currently trying to finalize those arrangements for where we're going to have it, but it's probably going to be the first week of December, targeting that Thursday. So stay tuned for more information there. And then upcoming in April 2024, AFCOM Data Center World's event is going to be there in Washington, D.C. this year. A couple things just to kick off the event, set the tone for the pace and discussion today, as we've done with all of our sessions, webinars in the last number of years. Start off with the president's message, identify who our community is and some trends that we're really seeing in the sector. First of all, you'll see there at the bottom, our community. Enterprise, hyperscale, third-party operator. Well, this is a chart that I'm taking from my own company's advisory services. And again, my name is Jason Shepard. Not only during my day job, I'm the managing principal of Cressa's data center practice, where we advise clients on multi-market evaluation, site selection, due diligence, market intelligence relative to data centers. But we look at data centers in three categories. Enterprise data centers, corporate America, okay? Then the middle category is the big internet data centers, the search engines, the large, mega scale campuses. And the last category is we call them third-party operators. So you might have carrier hotels, powered shell properties as a baseline, might lease to a wholesale colo provider who breaks it down to a retail colocation, suites, where you might have a managed services provider who might have a cloud provider. And blank, by the way, blank AAS is as a service, right? So you might have infrastructure as a service like an Amazon Web Services. You might have a software as a service like a Microsoft. But that last category, that 3PO category, it's really a stacking plan. And so what I want to make sure is that our corporate users that are out there aren't necessarily taking to heart, hey, what are the big search engines doing for their data center facilities? Because you're not comparing apples to apples. Yeah, you might still have a 2 megawatt Caterpillar generator, but your facilities are designed completely differently. And I know Yeet and Spiros will talk a little bit about that later today, because even a lot what we're seeing as far as these AI data center facilities, it's not the same thing as a corporate data center. And just because we're inviting or we're starting to adopt AI doesn't mean your corporate data centers are going to go away. So that said, our Southern California makeup, what is our population made of, right? So, and what I've done is I've taken the Orange County, San Diego, and LA business journals, and I've taken the top 50 companies headquartered in each market and looked at what industry segment are these companies in. Well, what you can see here is that none of these companies are those hyperscale data center facilities. Okay, so our populations, our constituents here in Southern California are the IT directors, the IT operations teams, and the data center operations teams for these corporate users, which are engaging with those AI providers, those 3POs, and those IDCs. As an example, one of the things I wanted to share here, just to kick things off, I'm going to move the views of our speakers up to the top, so when we're recording this, people can see. But AFCOM's State of the Data Center Industry Survey this year came out with the following, on the left-hand side here, you're seeing what are considered to be acceptable latencies for distributed IT infrastructure requirements. And for those who aren't as familiar with what latency is, so for example, if you were going to sync between your primary and secondary data center facilities in order to bid instantaneously, you've got to be within that kind of like that, those, call it that 30 kilometers of each other, or call it 7 to 10 miles in a central business district. If you go outside of that distance, there's a lag time. That lag time is called latency. Okay, so for example, in the AFCOM State of the Data Center Industry Survey, they've identified between all of their respondents to the actual survey that 30% of the actual respondents replied back that, hey, what's acceptable is that 5 to sub 10 milliseconds round trip latency. 18% was the next highest bucket, was sub 5 milliseconds. And then an additional 16% were up to 20 milliseconds. So down below or lower left-hand corner, you'll see that 64% of the respondents are sub 20 millisecond round trip latency. So what I've done here on the right-hand side is I've cross-referenced that with the long-haul fiber routes, what you're seeing in the middle of the screen here, and what those round-trip latency distance are to various metropolitan areas close to California. So for instance, Colorado, Denver's over 20 milliseconds. So for the majority of the population, that might be a bit too far, okay? And why I wanted to point this out is, and I've been doing data center site selection work for over 25 years. There used to be a magic rule of thumb of about 30 milliseconds. Now that's kind of shortened a little bit. Oh, am I still on?
Yeah, we got you, Jason.
Okay,
You're still.
sorry about that.
Yes.
This is stop sharing, and so I want to make sure I'm going back into my deck. Are you
We
seeing my
still
deck
see.
again?
We still see your map.
Okay, perfect. Perfect. So what you're seeing on the right-hand side of the screen here, for example, like round trip latency between Los Angeles and Phoenix, Arizona and back is about 10 to 11 milliseconds round trip latency. So that's within that acceptable latency for the majority of those users. Okay, so that's why I wanted to point that out, is because that's why we see a lot of our large corporate data center users for Southern California have their data center facilities in Las Vegas and in Phoenix, Arizona. That ties into the next slide here, which is this data report comes from Data Center Hawk. This is their second quarter 2023 overview, where they've identified that North America has experienced the largest single quarter of absorption of co-location data center space ever, with over 850 megawatts absorbed in the second quarter of this year. The most notable trend was driving a lot of that is artificial intelligence. And a lot of that is being funneled to the markets which have lower power cost and total cost of operation, with many of those AI requirements in that 1 to 5 megawatt range. The reason why I want to point this out specifically is that we've seen record-setting absorption in two of the largest markets, Atlanta and Phoenix, obviously Phoenix being one of the primary markets serving Southern California. And the second bullet point here I think of particular interest is that through fourth quarter 2020, there was 295 megawatts worth of capacity there in Phoenix. Well, that has grown by 375% since the fourth quarter 2020 to 1,105 megawatts in 2023. And they're still running out of power capacity in those markets. So it's a pretty crazy time in the data center industry today. One other slide I want to be able to share here is that, again, this is not just the big hyperscalers out in the marketplace. This is just looking at, for example, just the healthcare industry alone. And if you look at the HIMSS, which is the Healthcare Information and Management Systems Society, they do their annual survey of technologies and the technologies with the greatest impact in their 2023 survey over the next 3 years are, well, number one, telemedicine, not surprising considering the shift that we've gone through post-COVID here. But we started to see a normally risk-averse industry sector starting to onboard cloud computing services, artificial intelligence, and machine learning. But if you look to the lower right, the greatest impact technology over the next 10 years is AI. So really something to take in consideration. And the last two things I want to point out before we transition into our speakers is Omdia, who did their presentation at Data Center World, but also they just released a report on September the 4th, where they've talked about, look, AI is not just another flash in the pan. And many of the co-location providers that are out there to service these requirements are building their data center facilities now with higher rack power densities. And their comment is that those providers, those colo providers that can achieve those high rack densities and provide liquid cooling services are going to have the upper hand in the market. Now, my comment here is, look, if you're still a corporate user deploying your 30 amp 2.8 volt circuits, your 5 kilowatts of power per cabinet, hey, don't compare yourself to the AIs, right? They're not you. You're fine at your 5 kilowatts of power per cabinet. The challenge that ends up being is finding the available capacity for your uses today inside those co-location facilities. The bullet point there at the bottom, the projected compounded annual growth rate for the data center industry over the next 5 years is 9.4% per year. And then lastly, again, not all data centers can handle AI and HPC, high performance computing equipment. Omdia compares the AI market to the high performance computing industry that we see with the universities, for example, and the research institutions. But one of the things I'm interested to hear from Yeet and Spiros on the call today is, are those really in essence the same thing? Okay, so move on. Okay, so let's go to the supply chain update. Brad, you want to take this over?
Yeah, so good afternoon, everyone. Brad Schulteis here. Again, I work at LDP Associates. We're a manufacturer's rep for Schneider Electric, which is one of a handful of mission critical or data center equipment providers. Been doing this for about 25 years and never have I seen a situation like we've had for the last couple of years, where last year, if I told somebody they could get 100 kilowatt UPS in 6 months, they were ecstatic. We are in the process of recovery. What we're seeing, though, is still some of these significant components, and there's a lot of links in the chain that will definitely slow down the production of any new data centers. And Jason, I think it might be the next slide that has the specifics. There we go. What I did is I went out and did some research on just some general building materials, and then a lot of the mission critical infrastructure and IT equipment. And general building materials, we're still seeing up to a year lead time just to build the facilities needed to house this equipment. More interesting, even if somebody has an existing facility and they want to grow, they want to expand, air conditioning is probably one of the biggest problems we're having at this point in time. Air handling units are still well over a year, and chillers are about the same. The bright side to this market is for the smaller computer rooms, the MDFs. We're seeing a lot of improvement in the smaller precision cooling systems. Some manufacturers still have a year's lead time, but if you are open to looking for a couple different manufacturers, you can get some of these units within 12 to 22 weeks. That's just on average. Again, some of these manufacturers will have much longer lead times. When it comes to generators, we're still probably a year out. Obviously, this is sometimes manufacturer dependent, but switchgear across pretty much every manufacturer for line side switchgear for the facility, we're still a year out. This would be, I would say, 1,000 amp and plus. 50 to 70 weeks is very common across pretty much every manufacturer that I've talked to. Now, when we talk about lower voltage distribution, I would say the sub 400, maybe 800 amp, 8 to 16 weeks, but this really depends upon the configuration and what you're looking for in that type of electrical gear. That can be done a lot quicker, which does satisfy a lot of our smaller environments. Fortunately, large UPSs, those have come down significantly. Now there's an asterisk on that because a lot of times a large UPS might have a very custom bypass panel. It might be paralleled, and that could majorly impact the lead time of that system just based on the complexity of that bypass panel. But a lot of the off-the-shelf UPSs, along with VRLA and lithium batteries, can be done between 12 and 20 weeks on average. This is obviously manufacturer dependent. The bright side, the smaller UPSs, 4 to 16 week. And I said, between 20 and 900 kilowatt. I think as the larger you get, there's a little bit of, it has to be some flexibility in there. But I would say from our smaller systems up to 200 to 500 kilowatts, 16 weeks is fairly reasonable. And that's assuming there's nothing complex or nothing custom in the design. From the IT equipment perspective, Cisco Enterprise, there's a little bit of disparity here. 12 to 30 weeks is kind of on the average. I am seeing a lot of people saying they're waiting 9 months plus for some specific equipment. And I think if you are welcome to or open to considering other manufacturers, you might get equipment on site a lot quicker. And this is very similar to enterprise server and storage. Some of the complexity here is the type of machines you're looking for. And I would say the custom machines are definitely much longer lead times. So a couple bright notes to add here. Building materials on average have decreased by 1.1%. That was measured as of July of this year. That's a year-over-year number. Server room or data center infrastructure, cabinets, cooling, UPSs, in my opinion, is stabilized. I've not heard of any recent price increases, nor am I hearing of any future planned price increases. So I think we're pretty fixed from a price perspective. The real bright spot here, and this is a lot of what we have to do in Southern California, is the small computer room. The small computer room that would say maybe sub 100 kilowatt. A lot of this equipment can be on site within about 30 weeks. Now, obviously, this is independent of any custom equipment, but a lot of off-the-shelf equipment can be done in 30 weeks. And if we look backwards to 2 years ago, we were a year plus out. So things have gotten brighter. It's just in the large scale systems that we're still suffering. That's my supply chain update for you. I'll pass it back to you, Jason.
Great, thanks. One of the things I do want to share, went to the slide first, and this is the slide from Data Center World from the same State of the Data Center Survey 2023, where all the respondents to the survey, one of the questions they said, hey, has supply chain caused any outages in your facility? 44% of respondents have noted having outages as a result of supply chain challenges. So it is still something that we're dealing with. If you had participated in our session during the second quarter, we had our substation contractor on where they were talking about lead times for utility scale transformers were 2 to 3 years out. So we're checking to see if there's been anything, any substantial update on that. We'll report back if we hear anything different. But right now, again, supply chain is still a pretty big consideration. Moving on to our next speaker, let's talk with Todd Sword from Southern California Edison.
All right. Thanks, Jason. Thanks for having me today. Yeah, thrilled to be here. Glad to be a part of AFCOM, and obviously data centers and our major energy users are big customers. So happy to have a chance to work with you in any capacity here. Wanted to give you some overviews. Big changes happening at Edison over the last several years and the near future as well, the next 10, 15 years. We're really focusing on, safe, reliable, and affordable clean power, right? And the key areas that we're focusing on are strengthening and modernizing our grid, right? So we want to avoid wildfires and all the risks of that are coming from climate risk, but then also addressing climate risk, right? Partnering with the state to reduce our greenhouse gas goals to 1990 levels by the 2045, and lots of regulations in that space that we're trying to comply with and be a good partner. And doing a lot of that through that third bullet point there is about providing clean power and electrification, both of our transportation sector, but also building sectors as well, with the goal of getting to 80% renewable power by 2045. So a lot of things there, and I'll get into some of the details on the next slide here about what that's going to mean to our system. So next slide, Jason. Perfect. So, all of this takes time to build the infrastructure, but we're anticipating our load to grow by up to 80% by 2045 across our system to meet all these goals. And what does that mean? That means a lot more transmission lines. It means new distribution lines. We just heard today from our president that they're anticipating that we're going to be putting out 10 times the amount of distribution circuits that we normally do in a year for load growth, and up to 2 to 4 times on the transmission side. So a lot of stuff going on in that capacity. Statewide, we know that we need to get that 80% renewable power. We're going to need about 100 gigawatt hours of clean energy resources connected to our grids. So that's all coming. And then on the other side, right, we don't have, if we're doing renewable power, solar primarily, we need energy storage to take us through the evening, right? And that statewide is looking at about 30 gigawatt hours of bulk battery storage that we're going to need to meet those goals, about which 17 megawatts of that is going to be in Edison territory. And we've got about half a gigawatt kind of under construction. So we're moving in that direction. But again, all these investments have cost money, right? We've been spending about $4 billion a year for the last 3-4 years, hardening our grid. And thankfully, that's actually proving some great results. We're seeing our wildfire risk going and outages gone down about 75% since 2018. So, that's a huge difference, right? So no more fires ever again kind of thing. And we're going to make sure that that's straightened out. But also, now we have a much more resilient grid, and that's going to pay dividends for many, many years. But again, this load growth is getting, it's expensive to do this, right? Our new spend is going to be somewhere between $6 to $8 billion a year on infrastructure to be able to get all those new transmission lines, distribution lines, and two-way grids to integrate the distributed energy resources out there for renewable power. So that's a lot. But that doesn't immediately translate into higher rates, thankfully. We were talking about that yesterday on our teams, and we're like, no. There's going to be a lot more kilowatt hours going forward, right? And the idea on the affordability side, at least on the residential, is the total package of all your energy uses are supposed to come down overall, right? So as you substitute electricity for gasoline, you should get better benefits from that and so forth. So although on the industrial side, we're still got to work on how do we keep those costs down for you and all the major customers that are out there. And the last little bullet point there, we're really working hard on transportation electrification. This is a huge growth industry for us. We've got a lot of incentives through our Charge Ready program to provide charging infrastructure, both at multi-unit housing dwelling units as well as commercial sites. And we're seeing a lot of that. And Jason wanted me to mention something I talked about in our chat the other day is we're seeing a lot of EV charging hubs. So think of electric vehicle gas stations, but for electric vehicles and trucks popping up all over the place, whether it's for ride sharing or, I work in the gateway cities and South Bay region. So in and around the ports, there's a lot of activity to get charging hubs ready to handle the conversion of diesel trucks to electric for the ports. But starting in 2035, they're not going to allow any vehicles that are not clean energy vehicles in and out of the port. So everybody's getting ready for that. And what we're seeing is these projects are gulping up anywhere between 2 to 12 megawatts at a time. And so kind of the message to anybody, if your data center is growing, we heard earlier about AI, going to create an additional need for servers out there and obviously the power and the cooling to go with it. We need to know about those early because it's always kind of a first come, first serve thing. And when we work with our customers, like for example, some of these EV charging places, we do an engineering study and say, well, okay, you need 5 megawatts. Well, we can give you one now, but then it's going to take us 2 to 3 years to get you that extra 2, 3, 5 megawatts to get your power that you need for that site. So the sooner we know about this, the sooner you can get what's left, right? So you get first mover advantage there, but also gives our engineers time to start working on these new infrastructures so that we can do that. So that's
let me jump in and say one thing here, Todd, and
yes,
also
please.
for Brad's reference. If anybody does have any questions, please type those questions into the Q&A box. And we have David Sipes from our board is going to be watching those questions coming in. But again, type those in, and Todd and Brad, and then Spiros and Yeet will be on at the very end to answer the Q&A that we receive from the audience. All
right, let's go to the next slide, and then we'll wrap things up here. So, obviously we're committed through operational excellence to keep our rates down, right? And a lot of the areas that we're looking at now integrating is using artificial intelligence to drive deeper and find those efficiencies. So one of the things that we started an internal pilot program trying out generative AI. So we've got our own little personal chat GTP group and about 300 users that are trying to find new ways to find efficiency. So whether that's sifting through data or gathering information to automatically put together a report or a PowerPoint. So a lot of those things are going to be coming forward. So we're looking forward to leveraging that, which already people are freaking out internally, like, oh no, that means less people, right? But we're like, no, not necessarily. We still have a lot of work to do, but maybe new jobs versus some jobs would go away. And then a neat example that we've published recently is our data remediation tool, where our team internally worked with AI computing to look at all the web images available on the internet about Edison's structures, whether stuff that we've done or others have done, and comparing that to our system about what's actually located in there and what exact equipment is in there to kind of true up what's happening out there. And huge benefits in that space because, one, like for outages, we'll be able to respond more quickly because we're going to the right place where the exact infrastructure is broken, right? And then we also know what is that piece of equipment, so we know how to handle it properly. We have the equipment and tools to take care of that. So a lot of great opportunities there. And then just the man hours alone of not having to physically scan our every inch, a mile of poles and wires and all that kind of stuff. They've estimated is going to save about $8 million and 170,000. So a lot of good benefits on that one, and we continue to look for ways to do that. And then a couple of quick other points I'll mention too. We created our GIS Power Site Search tool initially to help data centers find large power sites that were power ready, if you will. And some of the improvements we've made on that over the last couple of years is now we've added not only the capacity on distribution circuits anywhere in our system you can look up, but also the substation that serves that. And then more recently, talking about automation and automating things, we're actually being able to provide almost real time the data on that information about how much capacity is left. So previously engineers would update that once a year. Now they figured out a system where, hey, high profile or high confidence projects will actually subtract load as projects get in the queue to take up that capacity. And then as engineering projects add capacity to regions, it'll show that back. So it's going to get even better. And so I encourage you guys, we'll send a link at another time. You can take a look at what's the power look like, where your buildings are at. And is it real tight? And or do we need to be worried, or do we have plenty of capacity?
Hey, Todd, so I'm going to throw a stumping question at you, right? And this is what we've always kind of told our clients from a commercial real estate standpoint is, well, just because you have a building that has a 5,000 amp or 3,000 amp power panel, that doesn't mean that power is still there, right? So what's the best thing for a customer to do if they're looking for a heavy power requirement?
That's my
Come
favorite.
to you and get a load verification letter. What's the best thing for them to do?
A couple things to do. So one, you're right. There's sort of 3 layers to make sure you know what your power looks like. So when people are looking at a building, hey, this is awesome. I got a 4,000 amp panel. Well, is the transformer a 4,000 amp panel? We just did a development where, the developer doesn't have a load schedule to say, hey, I'm putting all these servers in here. It's a 300 kVA transformer. That's not even, that's maybe 600 amps out of that 4,000, right? We've had another situation. Somebody goes, yeah, I got the 4,000 amps. Yeah, we got a 2,500 kVA transformer. No problem. Circuit, all that capacity is gone. That building's been vacant for a year and a half. That got gobbled up by all your neighbors. So all those things you need to find out. So one, you can use the tool to take a quick look. Second, you can reach out to us and we'll let you know what the power is there. And then if you're looking at adding power, we have a new level of assurance that we do. We do an engineering analysis report for fee that'll show, hey, this is how much power you can get immediately and how much down the line to meet your full power requirements. So there's a couple different ways, but we'll always give you a will serve letter. But that doesn't really get you much. It just says, yes, we'll provide you power, right? But it doesn't guarantee the amount for you specifically.
Yeah, I've always described the transformer inside the building or the power panel as the clown shoes, right? You got it doesn't mean you've got that amount of capacity. You've got to get your will serve letter, and you've got to basically, if you don't use it, you lose it, right?
Yeah.
So,
Yeah, that's
Todd,
very
thank you
positive.
very much for your time today. We're going to move on in the actual presentation here.
Sounds great. Thank you all.
Okay,
Yeah,
so I'm going to
so
turn
now-
it over to Yeet from
Is
EYP
this hold
Mission Critical
questions till the
Facilities.
end, or do you want me to ask it now? It's I
Well,
think it's
I think we want to make sure we're holding that Q&A to the
Yeah.
end.
okay. No
We got
worries.
about 30 minutes left here, and we want to make sure we get to Yeet's team. So, Yeet, Balut.
Thank you, Jason. Thanks everybody for jumping on. So we can go ahead and jump to the next slide there, Jason. So what we want to do here is that, generative AI and its impact on the data center has been sort of the latest sort of buzz going around in our space. And so what we decided to do, with Spiros, was we wanted to do a sort of a high level review of what that means in terms of trends. Then we want to sort of start looking at what it means as we start boiling it down to our end users and to our audience here, right? What does it really mean to you as a user, end user, owner, operator of a data center facility? And there are a couple of different perspectives on that, right? There's the how do you use AI and what that means in terms of the impact to your critical infrastructure on-prem. And then, and that's the last set of topics that I want to focus on is, if you are an end user and and you're not likely to become one of those folks that's developing a large language model to be used by millions and billions of people, there still might be some impact to your critical infrastructure on-prem in your own data center, and we want to take a look at what that might mean for you. So with that, what I'll do is I'll go ahead and hand it over to Spiros, and we will go to our next slide there, Jason.
Good morning, good afternoon. It's more like good afternoon for everyone pretty much now. Again, this is Spiros Leolis. I'm with EYP Mission Critical Facilities, part of Ramble. And the AI market, I was just talking earlier to another set of folks. The AI market has been really the most disruptive element, the most disruptive subject. And given the demands that we see here, everybody's wondering, what will ultimately be the impact on us, right? So let's talk about the generative AI, which appears to be the subject of the recent few months, right? It is anticipated that we are going to reach ultimately a market of 1.3 trillion. And while this is a very large number, to even comprehend, it is, most of the analysts, I would say all of the analysts are actually reaching out to this particular figure. So there's no doubt that the AI market in general is actually going to be in huge demand. Now we see this in what we call the three-phase roadmap, right? What we call the short-term roadmap is what we are practically experiencing today. Generative AI is being used for fun purposes. I'm talking about you and I writing, perfecting an email or perfecting some sort of an of a document, or making a quick question about a general query. I met a person who actually used ChatGPT to write a country song, although that shouldn't be very difficult. But in general, these are the fun and entertaining type of use cases, right? And we are also now beginning to see some sort of a edge AI type of use cases and how you can potentially decentralize part of the AI, simply because the amount of data that is generated at the edge is probably not very cost effective to transport them back into the big core data centers. And so we're saying, okay, can we at least analyze and process some of the data at the edge, right? The second part of the roadmap that we are seeing is what we call the made roadmap, and this is where we're actually going to see these use cases becoming a lot more, sophisticated. Right? They're gonna use more diversified content, especially. We're going to be seeing content coming from different industries and how we can share the experiences and the data from one industry to the other. So manufacturing will probably borrow from the supply chain. The healthcare is definitely going to borrow from biopharma. So the content itself and the data sources will get diversified, and therefore we're going to be seeing more and more intelligent use cases. And the third phase that we anticipate to see, by 2028, 2030, is the AI generated content is actually going to reach human level sophistication. This is the ultimate goal of Alan Turing, or at least this is how Alan Turing had described AI, is that the capability of generating content or having a conversations without knowing or without having the capability of telling who is who, right? So, and while this might sound a bit more like science fiction, the scientists and the technologists do feel that at that time we'll probably reach out to to this level of sophistication. And it's also the time where we say, given that the amount of massive data that we will be generating, AI on edge devices will actually be making real-time intelligence. They will provide real-time response. And of course, autonomous decision-making will happen, for the majority of edge devices that they have some sort of a decision-making capability. So massive growth for the AI trends, and all of the analysts are agreeing to these numbers. Can I go to the next slide, please? All right. So the impact of the generative AI when it comes to the facility itself is incomprehensible in some words, right? According to some of the models, right, the training of ChatGPT-3, which was the first version, and we're not talking about GPT-4 or GPT 3.5 or DALI or others. It practically consumed 1,300 megawatts of megawatt hours, and practically I think it emitted about 550 tons of carbon dioxide equivalent. So this is a massive amount of energy that we have so far consumed, and it was just the beginning. It was just the training method, right? Some of these models, or the ChatGPT-3s, for example, requires massive amounts of compute power, GPUs mostly, right? Especially for the learning from the learning cycle, but also CPUs, which is mostly on the inference. And I will explain a little bit more of that in a couple of slides, right? So, and again, the amount of power that is required, or I would say a data scientist pretty much estimated that the ChatGPT electricity consumption is probably close to, actually the number is probably a little bit invalid, is closer to 30 million kilowatts. So, and all of that runs practically from data centers. And these numbers will definitely become even bigger the moment we start hitting some of the more sophisticated use cases, especially for industries where there's going to be a lot of demand for, material science, right? We expect material science to be one of the most demanding industries. Of course, every industry will use some sort of synthetic data, but as these use cases become a lot more diversified and they use a lot of data sources from different industries, we do expect that the demand for electricity, for power, is going to grow exponentially. Next slide, please. So the data center has a dual role to play this. So what is really the thing that it's going to have an impact on the data center, right? The data center, for a start, is going to become the benefactor. All of that has to be hosted out of a data center, right? And the way we've been thinking about data centers so far is the 30-15-5 rule. What I'm saying is throughout the life cycle of 30 years, we have probably a couple of generations of MEP, and then every 5 years you have the IT. That's probably going to get disruptive. And the reason why is that the demand for AI is probably not going to be able to be accommodated by the IT systems, and the electrical and mechanical equipment will probably have to be refreshed with shorter timelines. So the data center will have to be the data center design part, right, and the design and the commissioning and the implementation altogether has to be rethought from the beginning, right? We're going to be seeing a lot more high performance computing, and yes, some of the companies are differentiating between HPC and AI. I spent a significant amount of time with an OEM vendor, and for the purposes perhaps of simplicity, for organizational reasons, HPC and AI is really one business unit for them, and it's usually true for most of the OEMs. But in general, as a general rule of thumb, the Gen AI will definitely require some sort of high performance computing. Maybe not the ultra dense, maybe the more medium dense HPC, but it's definitely going to rely on HPC capabilities. And the resilience of that critical infrastructure will be absolutely paramount. It's not just now asking, ChatGPT to write a country song, but it's now becoming, it's going to be part of the DNA sequencing. It's going to be part of, developing the next material. So resilient and critical infrastructure is going to be absolutely paramount. And we have to think of how we're actually going to monitor the infrastructure of these data centers, right? The DC models, or how to optimize the electromechanical. The generative AI will actually be built, right, for ways to how we can ultimately optimize the airflow, right, or the cooling process, etc. So the data center is the benefactor, but it can also be a beneficiary, right? They are considered to be old buildings, the lack of design. So we can now use ChatGPT, or I would say generative AI in general, to make these buildings, quote unquote, and apologies for the word, they're going to be sexier, right? They're going to be looking more pleasing. So we can actually get quite a few benefits, from these type of technologies, right? So the design, the operation, the optimization, the beautification of the data center is something that we can definitely benefit from. It also is going to help the engineers and the architects, which are, by the way, hard to get these days, right? They're going to have to, they can probably rely on these technologies to get conceptual designs, to get the high-level drawings. And then, of course, us as engineers will have to do our proper job, our due diligence, to make sure that, the single line diagrams, the electrical, mechanical, everything is actually, properly designed, right? And ChatGPT, or I should say, the ChatGPT type of solutions can actually consume all of those informations, because right now the TIAs and all of that reside on our heads. These technologies can actually consume all of these inputs, from uptime, TIAs, and everything else. Local or original codes can actually be consumed by the technology and provide the necessary, MEP, SPC outputs. Next slide, please. So the decision is, are we going to prem or, not to prem, right? What goes into the cloud and what goes into the prem. Spiros, is my data center now have to be rebuilt for HPC purposes? Well, not exactly, right? What we think is going to be a hybrid model, right? We think that obviously, Gen AI systems will if you have a use case where you are a very industry specific client with very specific intellectual property with very specific data, right, and you must capitalize on that particular data, on-prem has certain benefits, right? I mean, you can use that actual data without transporting them to the cloud, which is obviously a lot more cost effective, right? You can actually use all of these with making sure that you maintain your intellectual property and your private. But right, generative AI is an expensive technology, so it comes at a cost, right? It's also the supply chain, which it's already been mentioned. Getting this HPC equipment can have very long lead times. So and it's definitely going to require upgrading the facilities. So should you prem? I guess you need to balance the pluses and you need to do a cost benefit analysis and figure out, whether you should do that. Cloud on the other side, these guys, the cloud service providers, they have unmatched availability of such technology, right? They're spending, millions to deploy this type of solutions, right? And these platforms are their problems, they're not yours. So you as a data center operator and the user, you do not care how to ultimately make sure that, this system is running and, at its ultimate capability and capacity, right? And the cloud service providers, they already have huge anonymized data lakes where you can actually leech onto them and you can learn from these large language models, right? So they have also the necessary benefits, right? But they also come with the risks. IP leakage, right? It's a major concern, especially for many traditional legacy enterprises, right? It is very expensive, right? I mean, using the cloud in terms of the networking and the storage and the compute can be expensive, right? I mean, we already seeing the repatriation impact. And of course, there are some inaccuracies and inabilities to verify, right? We saw a six-finger Pope, right? An image that was generated by I think DALI or something. So there are things that the cloud is still hasn't gotten ready. So what we foresee, and if we can go to the next slide, please. What we foresee is going to be a hybrid model.
Sorry, quick question, Spiros. So when
Please.
we're referring to on-premises, right? On-prem, you're really talking about on an enterprise user's own IT infrastructure, whether that's in their own corporate data center or it's in a co-location facility. That's what we're referring to as
Correct.
Okay.
Yes, correct. Yeah, and then I should have clarified this, but yes, it is an own data center or a co-location data center. Correct.
All right.
So what we ultimately be seeing and where the market will probably settle is on a hybrid model, right? The learning side, right, which is the large language models. So the learning side is very, very compute intensive. So the propensity for cloud is much higher on the learning side, right? Because it requires massive amounts of data, right? And it requires massive amounts of compute resources. It's got to have multiple layers of neural networks, right? And these cloud service providers, they are built with that purpose, right? So it's more than likely if you as an organization eventually end up being or using, generative AI, more than likely the propensity of using, the propensity to the cloud is higher on the learning side. Meanwhile, right, because we spoke about the edge AI, you are still going to have, a couple of racks, maybe a few racks here and there at your on-prem, on your own facilities, or maybe your co-location, or maybe a future edge data center that it belongs to you, right? Where the compute are much lighter, right? I mean, think of your Siri and your smartphone. This is still kind of a device where you can undertake the inference component of it, right? And some of the sections that, some of the results do not necessarily need to be very, very detailed. Think of an AutoCAD, right? I mean, you can have the AutoCAD that has multiple layers, right? I'm speaking engineering language. I'm a mechanical engineer myself, so it's got multiple layers. It's got all that. But if you export it as a PDF, all of that level of detail has actually been compressed down to, a pruned item. So you don't really need the majority. You don't really need all of that compute power, right? It's a lot less. And of course, it improves the latency, especially for the more remote areas. So you as the user, you as the data center facility manager, you will ultimately have to become a broker between, what goes into the cloud, what stays into your own data centers. And you have to identify first, understand throughout these conversations, what will naturally go into one side and what will go into the other side. And secondly, you will have to manage these hybrid workloads. You will have to manage, the operations of moving back and forth data, moving back and forth applications, moving back and forth the learning and the inference. So your job now will actually become a lot more important. You will become a broker of all of these technologies. So I wanted to give in a few minutes, and probably took a little bit more longer than that, in a few minutes of what is really how we see generative AI impacting the world, the greater world of data center, both on the cloud service providers as well as the on-prem or the the traditional data centers. And now I'm gonna hand over to my friend Yeet to discuss a few more items on that subject. Thank you.
Real quick, Spiro, I just had a real
Yes.
quick question for you. Any statistics yet on how many industries are actually taking on AI? I know it's really been the talk of 2023. Any stats on how many industries are really dabbling in AI now?
Media and entertainment and design is probably the one that is capitalizing already on the use of AI. We understand a lot of the biopharma is actually developing, or at least investing money into this. But as of now, these are probably the only two top industries that we know that they're already doing heavy investments. But we do see that the majority of them will actually come part of the roadmap, which I shared earlier on, 25 through 28. This is where we're going to see more and more of these industries being more and more involved.
Yeah. By the way, everyone, from a time check standpoint, we've got about 9 minutes left in the original time. We can continue on from a Q&A standpoint after that, but I want to make sure that we have our time to get through Yeet's slides as well.
All right.
Sorry, I took time, Yeet.
No, that's all right. Yeah. So let's do this, Jason. Just do me a favor and just click a few times. Let's just get the slide all up there. So I'll just talk through it. One more. That's it. Thank you. So let's just take a breath here. And what I wanted to do was, with Spiros' lead up, and we were talking about this whole decision of on-prem versus cloud, why does it matter? Spiros referred to this, the 30-15-5 rule. And that was basically, if we could recap, it was this whole notion we're building buildings with an expected life cycle of 30 years. The MEP, that's the critical infrastructure that supports a data center, right, is on average about a 15-year life cycle. And then the IT life cycle, or the, whatever goes into the data center, right, was about a 3 to 5 year life cycle. Well, a couple of decades ago, and when we built and designed data centers and we were doing 150 watts a square foot, that was considered extravagant, right? That was huge. But that translated to roughly about 6 kW per rack. And most data centers at that time were averaging at most 3 kW per rack, and they had plenty of space. So what that really meant was that if you looked at that 30-15-5 rule of thumb, it meant that we could do anywhere from 3 to 5 IT refreshes within the MEP lifecycle of your data center, right? And so we coasted through that period of time for a good long time, being able to accommodate a lot of change in IT without having to really necessarily do any impactful change on our data centers. Well, then came along, the next sort of wave, if you will, and that was virtualization, right? The whole drive towards increasing density in the IT space, into the racks, and that started having more of an impact. Now, a 6 kW rack was the absolute bare minimum of a design starting point, and we were looking at 12 kW rack or more, right? Now, what that does is, as you start seeing this, is now that's starting to cut into our flexibility and our ability to survive IT life cycles with our existing MEP infrastructure, right? It's starting to get a little bit more difficult. Along the same time period, certain other things started happening, right? We started going to hot aisle and cold aisle containment models. Well, that had some, we did that because we needed to start increasing the density of our racks, but we also did that because we need to start thinking more about the efficiency and, energy conservation measures as well. When we started doing that, it had some other consequences. The raised access floor that we were designing as a default for most of our data centers, right, was part of its appeal was its flexibility. You could deploy IT clusters and data, a little bit more flexibility. You just lifted tiles, you got air, it was a blended environment. Well, as soon as you start going to containment and you're doing hot aisle or cold aisle containment, all of a sudden that flexibility is not quite there anymore. So you need to plan out, and you have these pitch, how much spacing you have between rows, and you have to put your IT in rows, etc. Along the same time, as these equipment gets more dense and as you get more and more equipment stuffed into these racks and they're getting heavier, Those two things and the drive to reduce the cost of data center construction to begin with, what have we started doing in the last few years? We've started eliminating the raised access floor. We don't do new data centers are pretty rare to go in with a raised access floor. Okay, all of these things, they were fundamental shifts, but we were probably still at the edge of being able to survive a IT refresh cycle. Well, now comes along generative AI. You know, like we were talking about, most end users, most of the audience on this call right now are probably not going to be in that market doing the large language model modeling hundreds of megawatts of generative AI on your own hardware. But there is going to be some components that are going to be on-prem likely. And if that's your data center, that means now that you're looking at different hardware, GPUs, and these things are much more denser or can be much more denser in terms of their rack density, 30 kW and up. Well, as soon as you get past 20 to 25 kW per rack, now all of a sudden cooling that load with air gets more and more challenging. And so we now start migrating into liquid cooling and other cooling technologies. Next slide, please. I can't see, my screen is blacked out, so. All right, so, looking at those trends again, we're talking about no raised access floor, containment, etc. What happens if somebody comes to you, your organization comes to you and says, listen, I have to deploy a higher density cluster, a few racks to do my inference engines because I need it for the low latency. It has to be on-prem. It's got to be in my data center. Well, if you're in an older data center and you have a raised access floor, that's probably to your advantage at this point, because now what you can do is you might be able to repurpose that raised access floor to get you some piping and distribution for liquid cooling solutions, right? That could be an advantage for you if you have a quote unquote older data center. What happens if you don't have a raised access floor? What do you do then? Well, if you have some real estate, if you have some space available, there are still some solutions that we might be able to develop that essentially gives you the opportunity to take a portion of your facility and to accommodate some clusters of higher density loads. I want to pause here. Something mentioned, Spiros mentioned, which was this notion of, is it high performance computing or AI? Well, quite honestly, all we're talking about here is the density of the load, right? If the rack density is going up, it's going to drive some of these decisions, and it's going to require some different ways of doing things. Okay, so what happens? What do you do if you're thinking about building a new data center? Well, in that case, maybe we need to revisit the decision of a raised access floor. But here, I'm not talking about a raised access floor that we're accustomed to in a data center, right? The 2x2 grid with computer tiles, raised access floor of that model. That's probably not going to be very practical, because as these loads get denser and you start using this as a interstitial space for piping and plumbing, if you will, then what we're talking about is some form of raised access floor that sort of splits the difference, right? It allows you to have some area that you can run this piping systems and do the liquid distribution, if you will, but it's a little bit sturdier and it doesn't require as much excess. You don't have to have it be in a 2x2 grid. A little bit of planning, maybe you come up with a system that allows you to have that interstitial space, a minimum amount of accessibility to get to the pipes and fittings, and to allow you to do some expansion, but it gives you some of that flexibility. Modularity, in our industry, modularity and scalability has been buzzwords and has something that we've all talked about for a good long time now. But when we're considering modularity, one of the things that happened in recent years in data center design is that we moved away from centralized chiller plants by and large. A lot of the newer data centers, went with distributed air handling units that scaled and could be deployed more modularly, right? Which basically drove us away from chiller plants. But if you think about it, we start looking at, liquid cooling technologies, it might not be a bad idea to start looking at modularized versions of smaller plants, or maybe an air-cooled chiller, maybe a condenser water system that is coupled to a particular deployment or a small module that you can build out. But it's in, and maybe you create a module that's air cooled for more of your legacy or traditional IT loads, but you could develop this other module that maybe has a coupled cooling plan of some kind that can accommodate liquid cooling, and you start mixing these technologies and deploying them. One of the advantages of
Can you pause for 1 second here? I just want to make sure for people who are attending the actual event, we're going to continue on here until we finish, but I want everyone to know that this session is being recorded. And so if you feel you need to drop and you want to come back in and just go back to the AFCOM national website, you can also check it on our own YouTube site. Just search AFCOM Southern California. You can actually see this full recording, but we're going to get to the questions that have been posed, and he's going to finish his session, but I want to make sure we're right at 3 o'clock. And so we're continuing on, but I want to appreciate and thank everyone for attending. So I'm sorry, back to you.
No worries. Yeah. So if you are considering a new data center like we talked about, one of the things that you can start thinking about is you can, if you're thinking sustainability and that is very important to you, remember, the very first thing and the key thing that you can do is anytime you can repurpose an existing facility, that's a sustainability win, right? That is, anytime you don't have to put another shovel in the ground to create new building or facility of any kind, that's a win in terms of sustainability, in terms of your carbon footprint. So a lot of these things will allow you to repurpose an existing facility. You can start looking at, if you have a facility that was not necessarily a data center, maybe it's one of your warehousing facilities or a warehouse, you can repurpose that facility to become a data center that might be able to accommodate some of these modular deployments as you develop them, right? If you think about a warehouse, they're typically, large empty cavernous spaces, typically not much of a roof. They're usually pretty flimsy in terms of those things. They may or may not have a good slab, and they certainly will likely not have very substantial electrical service, but they have space. And so if you have developed a modular deployment that can utilize some of these technologies that we're talking about, you might be able to use a warehouse space and start deploying some small clusters of a higher density compute, or even traditional compute for that matter.
Hey, what about multi-story office buildings that have been converted to quote unquote carrier hotels, right? So what are your thoughts on that? Because we went from having, those 8 to 12 servers per rack, the pizza box servers, to you start talking about the blade servers, only an inch thick, vertical, you can fit 80 servers in the same rack. These things are a lot denser, not just from a heat density standpoint, just a weight standpoint. So floor loading is a consideration. What are your thoughts on carrier hotels and their ability to kind of have that higher dense application and higher dense footprint?
So I'm going to take that in higher dense in two separate approaches, right? The first one, let's talk about the physical, right? In terms of the weight and the low density on the floor. The reality of it is part of the challenge when you go into a high-rise building, an existing building in particular, and you're trying to put these denser loads in, the challenge has always been that those typically did not have a lot of floor to slab clearance to begin with, right? So one of the ways you can always, deal with weight or physical density of load has always been to, you can spread those loads out across a steel system or grid system or something like that. And you can still do that. The challenge with that, of course, is that if you don't have slab to slab clearance and you're starting to put the superstructure inside to try to support higher, denser loads, point loads, right? You're eating into your slab to slab clearance, which if you're trying to do air cooling, and conventional cooling, presents challenges. So it basically makes it more difficult. Now, on the flip side of this is if you start looking at liquid cooling as a solution, now all of a sudden you can probably sacrifice some of that slab to slab clearance, and you might be able to actually use that steel superstructure that you create to support some of these denser loads to create that interstitial space for your piping and liquid distribution. So you might be able to, ironically, be able to support these things, working within the physical constraints of the space you're working in, right? And that's kind of where we come in. This is part of what we do, and something that we're particularly good at is, looking at how we can repurpose and take a look at these existing sort of applications and come up with solutions to meet the need, right? But yeah, Jason, it's very challenging in high-rise buildings, especially with low ceiling to slab clearances to get high density loads in. And historically, because you can't add any superstructure, you can't do anything to spread the load, it was more difficult. But liquid cooling might actually provide you with some solutions that are viable in that space as well.
Right.
All right, so next slide. I wanted to sort of, we've talked about AI, we've talked about its impact, but I just want to remind everybody, so your data center doesn't care what the load is, right? If you're own and operate a data center, your MEP, your mechanical, electrical, power and cooling infrastructure really doesn't know what your load is, doesn't care what your load is. It's vendor agnostic, it's load agnostic. Assuming there's space, assuming that you have within the confines of your power and cooling capabilities, that data center is going to provide what you need for it, right? So whether it's high performance computing, bit mining, though, they have a different reliability requirements, et cetera, or generative AI, any of those things, the key is not so much, what the load is or the IT is. Obviously, we care how to service it and what it means in terms of reliability and how we're going to service those loads. But, it always comes down to the fundamentals, space, power, and cooling. And so to the extent that your data center, we can accommodate a lot of these solutions as long as you have those things. And part of it would be to decide at what point we upgrade those things, change those things to accommodate the new services and the new demands on your data center, right? So with that, I think I'm going to go ahead and let take a question and answers at this point.
Great. So what I'm going to do is I'm going to stop sharing, and I know that I think we lost David. So we're going to come back
might
to
be problematic,
the remaining panelists on the board. And so let's see. We got some questions that did come in. And I'll read them up front. So we had Brent Goran said, what is your current rate of capacity growth versus demand? I'm not sure who that was addressed to, but it was midway through the actual session.
Edison.
Yeah, I was going to, if I had to guess, I'm going to say that's a Todd question.
Okay.
Yeah, I was I was shooting questions to my engineers. One of them wrote back and said most of their projects are growing about 2 megawatts per circuit. So I don't think that's system wide. That's just per project. I also looked up what's the peak load that we've seen in California, historical trends. And it's been averaging around 46,000 megawatts per year. But last year, we actually hit a peak of 52,000 megawatts. So pretty big jump. But yeah, I'm still digging to try to get an answer because that's a great question. All my engineers are like, yeah, we should know that. So I'll get back to you guys on that.
The next question was, do you consider the next gen will be AI server only? I'm assuming that's next gen.
I'm assuming that's next gen, and I think it was while I was talking. In all honesty, the chip development itself, the whole site will naturally get closer to AI, right? I mean, look at, just take the most basic Apple laptop these days, right? I mean, they have the M1, M2, M3s, right? Where they have packed CPUs, GPUs there, and they have their internal AI. So yes, overall, the next generations of chips are going to be more and more power around AI, right? Will these systems be enough to run, the HPC type of workloads? Absolutely not. So I think we're going to see still the GPU, still the CPU. We're going to see hybrid chips, right? So I don't expect a only kind of chip. I think it's going to be still a large variety of different chips.
And from an infrastructure point of view too, I think that the thing to keep in mind is, again, remember your data center doesn't care what your load is, right? And so what it means is that as the densities increases and as we get more GPU and application specific developments going, yes, the loads are probably going to get more dense, but in the end, what it's going to mean is that we're just going to have to adapt the way our infrastructure services those loads more than anything else. Right, and the fact that it's a AI machine or a rack full of GPUs versus blade servers versus SSID storage, is not going to make a difference in terms of the load. It will make a difference in how much reliability we put into servicing it. It will make a difference in how dense it is physically, weight considerations, for instance. But, these are all things that, from an infrastructure point of view, we can accommodate.
One of the questions that I had in the spirits, I guess this is a question for you. When they're comparing generative AI to high performance computing that you've seen with the research institutions, which in my experience working with the universities and healthcare systems, they need a lot of power infrequently, and they really didn't care about the reliability and redundancy of the actual data center facility. So with these AIs, I'm assuming so are they looking for high levels of reliability and redundancy like a corporate user would? Are they just looking for the straight capacity to fry the egg, right? And then the second follow-up question to that is, does the round trip latency between the AI and the customer make a difference, like it does in cloud solutions, but not necessarily the storage arrays in research?
So the criticality and availability will depend on the workload itself, right? If it is just a typical ChatGPT kind of a questions, the level of criticality is, I don't want to say irrelevant, but it can be of lower. However, it is the learning mechanism that we got to get right? And that is why you can't go wrong with the learning, right? You can't teach that there are 6 fingers people, right? I mean, I'm using the dumbest of the examples, right? So you must absolutely have the learning cycle of AI, the generative AI, correct, right? Because you are ultimately delivering results. You're ultimately delivering conclusions from the learning side. Your inference will naturally depend on this. So it's absolutely paramount that we get these type of workloads correct running, because we cannot afford mistakes. We cannot afford lack of punctuality, right? So it's absolutely paramount. Now, the question about availability or the network connectivity and latency, well, again, it also depends on the workload. If your Apple Watch or smartwatch or whatever device, medical device watch relies on some sort of a response, you want it right there instantly. So yes, the network is paramount. If it's for a social networking kind of an activity, okay, no, you can probably live without your Instagram for a millisecond or not, right? Or something like that. So it all comes down to,
I think there are a lot of people who would disagree with you on that.
Of the younger generation,
I actually
Just
used that
saying.
very same example with a bunch of students. They said, "What do you mean you cannot live without Instagram?" I said, "I'm sorry, guys, I'm not an influencer." But anyway, but you're right. You're right. It probably used a dumb example, right? But it has to do with the criticality of that workload itself. Why do you need it for? For again, medical reasons, instantly. But for some not so so life threatening, okay, you can probably live with a couple of milliseconds later on.
Well, that's why I use specifically. We could talk about AI in the financial services sector, which is probably the top of the food chain when it comes to mission critical type of facilities. But you can't get more mission critical than healthcare, and that's why I chose to use the HIMSS research survey of how the healthcare industry in the next not only 3 years, the next 10 years, AI is going to be at the top of that food chain.
Oh, absolutely.
As far as technologies, and look, if I'm in surgery and there's an AI, that's pretty mission critical. That's pretty latency sensitive.
Yeah.
So
and
I
it's
think
really important.
Those are probably.
It's important. Go ahead, Ethan.
And actually, those are probably the use cases where the decision to on-prem near the hospital where the workload is going to be more critical than on-prem in a service provider remote, right? Because in years ago, that was part of the OSHPD considerations too in California in particular was, is it a requirement, for critical and life safety systems associated with, hospitals and et cetera, does that have to be on-prem on the campus of the hospital, or does it, can it be remote, right? Because there was a lot of consideration on, if I'm basically doing think about it. We haven't had classic X-ray films in probably a decade, right? Almost all radiology and all imaging is digital now, right? Well, if you're doing a digital image of somebody's, basically, in the ER and has a broken arm, that's one thing. If you're doing a cath lab where somebody's getting an angio, so totally different use case for that digital imaging, right? And these sorts of things matter. And in terms of reliability, Spiros was talking about how media and entertainment, were probably the first sort of people or the groups of folks that were starting to use, AI. Well, they were using high performance computing before, right? Because all these CGI rendering, right, has been around for years. It's just gotten more sophisticated. In that case, what would happen is it was batch based, right? So you would take run a batch of renderings, and if during that rendering process it went down, it was a little bit of downtime, but it was no big deal. But the main art, the sort of the IP, if you will, of that product had to be in storage, and that had to be sacrosanct. That had to have the high reliability, and it had to have, you couldn't afford to lose that. But how you rendered it, how you used it, that was more batch based. And there are certain things that are probably still that way that you can probably, go ahead, Spiros.
I was going to say, sometimes we live in a kind of an ivory tower thinking that the whole world is like the United States in terms of networking and capabilities. But then you've got a very large American fish farm that has, a production down in, South America and Chile, right? And the chemicals within that water, because of the fish farms, is actually requires immediate response for the chemicals, right? Sometimes you may not have that infrastructure. So you may not, the latency is so far out, is so long that you cannot accommodate it. So you really need to have that processing capability, that decision making power on the site, right? To say what is the sort of a chemical that must go into the fish farm. It's a real story, by the way. But you also need to have learned. The learning cycle of it must be absolutely correct, so that you say, okay, I am now putting the right chemicals for the right amount, for the right time, at the right temperature, etc. Right? So it's both very, very, very critical.
Well, I know we're severely over our time. We've gone almost 20 minutes over our time, and so I thank everybody for sticking with us. The one thing I will guess from a closing statement standpoint, we've seen over the last number of years the evolution of what we call hybrid co-location. Go to co-location facilities where there's that ecosystem of cloud solutions that customers can cross-connect to, that migration to cloud, and a lot of repatriation back. And that in my 25 years in the data center business, I've never seen a time like this where there's so much absorption of capacity from not only a cloud standpoint, from an AI standpoint, and it's having an impact on the corporate users who are trying to come back. Right. So it's really an interesting time. It's a very exciting time in the marketplace. There's a lot of expansion. There's still a lot of lead time items from a supply chain standpoint, but the future is very bright for the data center industry. I'm very excited for it. I'd like to thank our speakers today. Todd, thank you very much for participating and adding in the Southern California Edison perspective. Obviously, the Yeet and Spiros, the EYP team, who's been somewhat of a mentorship group for me in my career. Thank you so much. The rest of the board who's still on the discussion today, thank you very much. We'll go ahead and adjourn, and look forward to seeing everybody at our holiday social in December. Check out our website. Check out on our social media on both Twitter and on our on our LinkedIn.
Am I invited? I'm based out of Atlanta.
You can come on in. I hear Southern California is not that bad over the holidays.
I'll make it work with Heat. Yeah.
Yeah, you can come anytime you want, Spiros. We'll leave the light on for you.
Right.
All right. Thank you.
Well, thank you, everybody. Thank you very much, and everybody have a great weekend, and we'll talk soon.
Absolutely. Thanks so much.
Thank
Have a good
you.
one. Bye-bye.